Okay. Good evening, Vamsi.
Good evening, ma'am.
Okay. How are you?
Yeah, good.
Okay. Okay. Can you introduce yourself?
Hello, can you hear me, ma'am?
Yes, yes. Carry on. Can you introduce yourself?
Yeah, ma'am. Hello, my name is Vemanaban Vamsi. So I have completed my master's from IIT BHU Varanasi in the year of 2023 from EC, the stream of Electronics Communication Engineering. So sub branch of Digital Technical Instrumentation. So where I have done my project. So I have completed my undergraduation from NBKRIST. It is located in Nellore district in Andhra Pradesh. So I'm from Andhra Pradesh. So I have completed my project on based on this immersion algorithms on the chips. So it got published in IEEE conference also recently, and I have worked on in Intel as an IP logic design engineer as an intern for 1 year. So where I got profound knowledge on Verilog and IP logic designs and digital design, and I have done some courses and verification courses. So where I have involved in some decent verification projects, and I have a very good. I'm very good in SystemVerilog and UVM. So yeah, ma'am, that's it.
Okay. So, so you have worked in Intel as a
Yeah, ma'am.
internship
Yeah.
as a IP logic design engineer, right? So what is
Yeah.
the role, your role in there?
So it is in the first stage of FPGA design flow. So where I have worked in FPGA department. So it is like we will have an continuous touch with spec department, architecture department. So based on the specs and architecture documents they have released on the project, we have to understand those docs and specifications. We have to design the modules using Verilog, and that was my main role. And after that, where I have profoundly involved in this physical layer IP. That is an IP that was main in every physical in FPGA boards. So there I was there for 1 year, where this entire big project called sorry, I cannot disclose the information. In FPGA there was for 1 year the physical layer IP, where this is the analog. Where is the physical layer in the sense? This is the entry point for any FPGA. That analog information will be converted into digital information. So inside that, some blocks will be there, PCS block, PMA blocks. So inside that, some serialization and deserialization blocks will be there. So based on the subsystem of the design of the FPGA board, we have to incorporate what are the specifications. Based on the specifications, we have to connect those blocks inside, and we have to just normal do verification, and we have to send it to the verification department.
Okay. What type of verification you have did there?
It is just like normal Verilog verification. It is like internal verification. It's nothing to
Okay.
do with system Verilog. Just to check our design is perfect or not in VCS simulator.
Okay. So how you designed, what is the design, internal design?
Then in the sense, just like one of the main IP I have owned there, it's like a set reset controller IP. So in
Okay.
every device, there will be an initial stage where initial in boot up, power boot up, the system has to load with some register values, and system has to be with some states. That will be called in a reset stage. So I have designed that. I was a part of that design team where team was designing with that set reset controller IP. So there is a key part in RFPG on that day.
Okay. So you
Yeah,
have done
based
some
on that,
yes, yes,
yeah,
go ahead.
that set reset controller, it is like mainly focused on the register values. So based on the what register values we have to put, that information we will gather from architecture department. So based on their requirement, we have to write our codes, and we have to incorporate the logic.
Okay. Okay. So you have done some PG project, right? Related to FLT and ITA.
Yeah.
So what is that block level architecture?
It is a block level architecture on inversion algorithm. Actually, most of the it has a main importance in cryptography. And one more thing was most of the computers now we have Intel processors and media processors. So what every processor will be do normal operations like addition, subtraction, multiplication, division. So division is the one of the key aspect that we have to work on every time, because that is the operation where it will cause so many resources. So we have started in that aspect, and that earlier it was that entire inversion algorithm was designed using square blocks. So our me and my professor worked on it, and we have redesigned everything with algorithm and formulas which will work on quad blocks. So it is like inversion algorithm in the sense, just like when we are trying to find a value, like a divisible by b. So these NVIDIA and Intel processors, what they will do is first they will inverse, I mean b inverse, and then they will multiply with a. So then finally they will got a by b value. In that fashion, these processors will calculate their inversion value, division values. So in that area, we got some good results on it, and we have reduced 13.2 percentage of LUT count. So we have implemented that entire architecture in FPGA board, uh, Xilinx FPGA. So we got profound results where we have reduced 13.2 percentage of LUT resources, where it costs in a square block. By using quad blocks, we can reduce other those 13.2% LUTs. So that was our main aspect, and we reduced the power also. And so on that way, we presented paper in IEEE, and it got selected and it got published also.
Okay. Okay. So what are the challenges you have faced while doing these projects while uploading to the IEEE?
Yeah, it is like so facing issues in the sense of we got the results finally. We know that we are up to the standards that this paper will get selected by IEEE and in profound whatever profound publication. But whatever is presenting the way will be some more important. Luckily, I have a professor Kishore Sarvadekar sir. So he's very senior. He got at least 20 papers in his career. So he knows how to design the paper. So what I just give the content, and with the help of my professor, we redesigned the paper, and it got selected. And it got some comments on it, some updation on the comment for some updation, and we again did it that, and we sent it them, and finally over, and now our paper was got published.
Okay. Okay. So as this is the SOC verification role, how would you rate yourself in SOC verification? Have you done any project in that?
Yeah, I didn't do any project, but what I feel is, if I know that basics of what are the job role needs, I don't think I need that much time to understand in the project, because I have already have 1 year in the experience in the industry. I know that I understood that how that industry works, and how the teams works, and how the this development flow works. So as far as that, what are the skill needed for this SOC design role, where your SV, SystemVerilog, UVM, test benches, and everything. I have a profound knowledge, and I have done some verification projects. I know how this UVM and SystemVerilog can be incorporated for the verification of the particular design. So in that aspect, I'm very good with the skills what that need in that role. I don't think I need much time to look upon the projects in the next sessions, because I have a confidence that within less time I can be in the position where the task will be managed by myself.
Okay. Okay. So then what are the different blocks involved in the SOC architecture? What are the different teams involved in the SOC level verification?
For sure, we have to keep on work with the design team. So, and where we will get the specs and how this functional blocks will work inside, and maybe the protocol teams. What are the protocol that were designed inside the system? Different system blocks. We have to get in touch with those teams, and
Yes.
yeah, ma'am, that much knowledge only I have on SOC verification.
Okay. So what are the different blocks involved in the SOC architecture? Can you draw a simple SOC and what are the different blocks involved in that? You can share your screen and you can draw.
So main thing will be we will have a bus and those blocks maybe blocks and we can connect with the peripherals.
No need to write, just explain.
And in SOS we will have what are the blocks? Maybe it's memory block.
What are the
And
subblocks in the memory block? How can we access memory block to the processor? How handshake mechanism happens between memory and the processor?
sorry, ma'am.
How handshake happen between memory and the processor? Like register mapping, register read, register write.
Yeah, ma'am. So based on the signal, what is the write enable or read enable? So some signal based on the signals, so processor will get to know that whether they have to write or read, and based on the address. After that, based on the address, we will retrieve the data through the data bus. Actually, there will be on two processors here. One is a Von Neumann and Harvard architecture, two different type of architecture. So in the new method that is in Harvard architecture, we will have a different instruction. For instruction, we will have a instruction. For address, we'll have different bus, and for data as well as data. So we can parallelly at a single particular time we can do both. We can retrieve the based on the retrieve the data. Okay, sorry, instruction and data. Based on that, we will at a time we can do we can retrieve the instruction or we can retrieve the data as well as we can send the data also. Whereas in that one human architecture, we can do it at either it is an instruction or data. We can do it either one. We cannot do both.
Okay. What is the difference between IP verification and SOC verification?
So IP verification is more of like it is a single block. So it is a verification is more of like it will be a single protocol, maybe IP in the sense it is like a intellectual property. It will have single motive how that works and how things will be inside. But as compared to in SOC is an amalgamation of so many blocks in the different types of IPs. So incorporation of those IPs to the buses and interlinks between blocks and connections between the buses and these interconnects and everything will be there.
Okay. So how would you rate yourself in SystemVerilog and UVM?
In SystemVerilog, I can rate myself 8 by 10. In UVM, I think 7.5 by 10.
Okay. Okay. So in SystemVerilog, how you generate the coverage? Like, can you write a problem statement? There is a address
Okay.
of 4-bit. Address size is 4-bit. And data size is 8-bit. Data
Data is
1.
8.
Data 1 is 8-bit. Data 2 is 8-bit. Output is equal to data 1 plus data 2. So here we are generating address is less than 100 using randomization.
What is the randomization, that range?
Address is less than 100
Okay.
and data 1 and data 2. Data 1 must generate odd value. Data 2 must generate even value in randomization by using the constraint.
Yeah. Okay, ma'am. Sorry.
So after generating these values, we need to do the coverage analysis to get 100%.
Okay.
So how we will write the program? Just assume like some random values are generated and how we will write the coverage code. You can write the logic now.
So only for coverage or entire from module to say
For
randomization everything.
randomization and coverage.
Okay. Okay, ma'am. So we will remove this out so that we will feel that some module was there that is a design module. It is an adder module,
Okay.
so that I can remove this out signal.
Okay.
So address is less than 100. So that address range should be here. So for less than 100, I have to convince this in so 6-bit 64, 7-bit 128. So I will have to take the 7-bit value so that address should be less than 100. And, just need to so where I have to generate data 1 as an odd value. Yes. So D1 is data 1 percentage 2 will be an odd one. So that is 1. And I have to data should be an data 2 will be an even. So it will be 2 class. So initial button. So example will be instance. I will give a handle even. So we will give a constructor for even. So after that even dot randomize. Yeah. So now we will write a coverage. So we will try to go for cover group. We will write the cover points here. So inside that, address is 100. Okay, anyway, so out is data 1 plus data 2. So I have to concentrate on data, and so I can segregate data anyway. So the maximum value of D1, D2 will be an 8. This is an 8-bit value. So 2 power 8 is equal to 6. Max will be 255. Data 1 will be 255. Data 2 will be 255. So its maximum will be 10, 11.
You can generate for all scenario or some separate scenario you can take and for example you can generate.
Sorry, ma'am. Hello. Can you repeat?
Hello. Yeah.
Yeah, ma'am.
You can generate for separate scenario or you can generate for all scenarios.
So, ma'am, from 0 to 255 will be one scenario, and the 255 will be on one scenario.
Yes. I mean, for randomizing, you are generating only for particular constraint, right? So what value will be covered? Accordingly, you can write the bins. Actually, we need to generate for 100%. That means we need to cover all the bins, uh, all the bits, right? So, but here,
Yeah.
for example, whatever you are taking, whatever the randomized values is getting, so you can do accordingly. Suppose for constraint, second constraint C2, odd values are generating. What odd values will generate? Okay, you can take only from 0 to 100. Okay, 0 to 100 means between 4 bit or 5 bits. Okay, so like that you can cover in the bins. Bins is nothing but the particular bits. What is the functionality will be covered, right? So accordingly you
Yeah.
can write. That's what I'm telling. Otherwise, you can take the constraint for odd value. Don't remove all. You can take the
No, no.
constraint for second constraint. You can take like odd value should be generated between 50 to 100 or 50 to 200, and also even value should generate between 50 to 200. So within that,
Okay.
what bits will be covered in the cover point according to our functionality just now itself.
Okay. So why I
Yes,
copied? Because within 10 minutes this session will end. So we have to restart it again. So I copied this code.
it's okay, no problem. You can cover.
42, 5, 1, 150. So D1 will produce 150 to 150 of odd numbers, and D2 will give an even number.
So for A1, what bins will be covered? What is
So
the
it is like
syntax? Have you remembered
so
syntax?
I am that's what I'm remembering.
Okay.
Actually, I'm trying to segregate 50 to 50 to 150, 50 to 150. That max will be minimum will be 100 and max will be 300. So I'm planning to two bins 100 to 200 and 200 to 300. Two bins. Yeah, here I'm that syntax I'm trying to remember that how out that bin will be covered.
Okay. Okay. I will give you a hint.
Yeah.
So, okay, you have written right. So, bin 1, you are covering 100 to 200. Why 100 to 200 you are covering? What about 50 from 50 onwards?
No, ma'am, it is like 50 to 150 range both are. So
Mm,
minimum
yes.
will be 100 and max will be 300.
Okay.
So 100 to 200, 200 to 300.
Okay.
And this syntax I'm trying to remember, not able to because I didn't practice much in this coverage. Now I realized. Can you help a little bit? So I'm not able to remember that.
Here you are writing correct only, but whatever you are taking um, from 50 to 100, you are not covering.
No, no, minimum will be 50 and minimum will be 50, ma'am, both sides.
Yes.
So
Yes.
there won't be any case of 50. Minimum will be 100.
Okay.
So minimum value is 50 and D2
How
minimum
many
value is 50.
bins you want to take?
That's just like two bins. So this is a minimum of 100 and max will be 300.
Okay.
So just in a simple case, I'm splitting into two bins. One is 100 to 200 and another is 200 to 300.
Okay. So is that your answer? N group. You have written N group also. Okay. Fine.
Yeah.
Okay. Next question is, what is the difference between dynamic array and associative array?
So okay, this dynamic array and associative array is a new topic in SystemVerilog that was not in Verilog. So dynamic array in the sense we don't specific the size. So dynamic in the sense we can change the runtime. So as the name suggests, we can vary the size while we are in a run stage of the program. So we have a flexibility that we can change the size of our array according to store our values. So that was one aspect in this one dynamic array. Associative array is when we don't know the size, what exact size we need in that operations inside this code. In that case, we will move to associative array. So the notation difference will be there. It is like for dynamic array. It is like a open bracket and close bracket, and we don't specify anything inside it. It will just left it as a hello. But in in associative array, we will we will indicate it as a with a star symbol, asterisk symbol. So while running time, so this associative array where it will be useful is in operations we don't know how much size that particular variable need to store, will be the size of the variable. Just to store those kind of variables, we need associative array.
Okay. Can you share your screen?
Yeah. You need to give permission.
Yes. You can share now. Okay. In a design, can you write? In a design, there are uh, 4 command inputs like addition, subtraction, multiplication, and division. Addition is command 0, subtraction command 2, multiplication command 4, division command 6. Subtraction command 2, multiplication command 4, division command 6.
Multiplication command 4.
Subtraction command 2, multiplication command 4, division command 6.
Okay.
Okay. Now for command 0, inputs of data 1, data 2, addition of data 1, data 2. For command 2, subtraction of data 1 and data 2. For command 4, multiplication of data 1 and data 2. For division, data 1 divided by data 2. Okay. So these are the inputs. So what is the output? Output is output 0, output 1, output 2, output 3. 4 outputs for 4 commands. Okay. So I need, how do you interface this design, okay, with the SystemVerilog test bench? Means interface, how you write the interface block using mode port and blocking block connections.
Okay.
This is the specification from design side. In verification side, you need to do the interfacing between design and the test bench. So need interface diagram, interface block. You can write again, that will not copy.
Here. And so data will be 4-bit values, D1 and D2. And so for we will take an out to which will be an interface for this is an output for multiplication value. So I'm creating a command signal which will select these either of these four signals: add, subtract, and
In
multiply, division.
interface, will we write bit data type or logic?
Everything will work. Okay, yeah, logic is more preferable.
Okay, fine. You can write your code.
So inside this, we will have a clocking block and mod port. So clocking block. So we have to give Q values using equal to input Q to and output. So here we will make the connections. Can you help here? How I forgot that connections. What are connections we have to mention here?
Mostly we'll connect with the interfacing with the driver to the DUT and monitor to the DUT, right? If you want
Yeah.
to take two clocking blocks from monitor and driver, you can take two clocking block or single clocking block is enough. So you can put here driver clocking block. You need to take the instance of the driver here CB1, right? So with that instance, you can ports, whatever the ports are there, you can apply those ports here. You need to check how you need to put, like clocking block means what are the inputs, what are the outputs. Mod port means what are the input, what are the output. That will be different. For driver and the monitor, it will be opposite. Have you understood?
Okay. That input it is a bit T1.
Simply you can write what are the inputs, what are the outputs from DUT to DUT. So whatever you are writing for the driver, that will be opposite for the monitor.
Yeah, for monitor everything will be an input.
For mod port, you can write directly instance of the clocking block, comma, clock and reset will be separately. You can put.
So instantiation of DUT, suppose. Input. Actually, here we'll have a clock and reset block. So that was a global signals. We will keep them as a global signal. So as it we are making keeping it is as a combination block, we are not doing any with any work with clock here. Otherwise, we would have an at the rate of a passage clock syntax here.
Okay. Okay, we'll go with next question. No problem.
Okay.
So why do we need
regarding this
virtual
question, any suggestions here, ma'am?
Just you need to check while taking the variables here, you need to mention the logic data type. So you need to remember the syntax here, how you can use the logic. Okay. And clocking block also, you need to use the syntax and why you have taken that hash to skew. Okay. You should have the justification on that, why you have used hash to. And coming to syntax wise, what are the inputs and what are the outputs for the driver clocking block and the monitor block clocking block? If you go practically, mostly we use the two blocks because synchronization both sides important, right? That's why.
Yeah.
So you need to check the where we need to put the inputs and where we need to put the output. What are the inputs? What are the outputs in the driver and the monitor? Same for mod port also. Mod port is simple. If you write the clocking block, same signals also for mod port. That's why without writing again all the inputs, all the outputs, we can just put the instance of clocking block and you can add the clock and reset signals if any extra signals are there. So that is the mod port.
So here on point, ma'am, I want to add, I need to correct. So here we can put it as a hashtag 2 nanoseconds also. But here it is just like mentioning whatever the time directive we have defined in the program previously. So it will take that time step here. Am I correct or not?
Yes, according to that only, according to the macros, this time skew will be calculated.
Okay.
You can put nanosecond or picosecond like that. Here you no need to put just #2 or #1 like that. It's enough.
Okay. Okay.
Okay. So
Okay.
next, coming to the UVM. So what are the different phases out there? What is the importance of the phases in UVM?
Okay. to maintain synchronization between the processes, we will use here phases. Actually, in SystemVerilog, we have a concept of semaphore, which will be which will be used to synchronization. So, but here in UVM, we have separate concept of phases. So here we have 9 phases total. So it is like first one is a build phase, second one is a connect phase, third one is a end of elaboration, fourth one is a start phase, start of simulation, and fifth one is a run phase, and sixth one is extract phase, and seventh one is checking phase, and the eighth one is report phase, and finally is final phase. So among all of these, run phase is a main phase where this most of the time consuming of execution will be happen. So it is like remaining phases, everything will be in execution stages. I mean, execution time is not that much lengthy. So yeah, ma'am, that's it. Those are the 9 phases that we have in UV.
Okay. Okay. Have you worked any projects in UVM?
Yeah, ma'am. It is like still the router projects. I'm still able to. I'm still doing that. Actually.
Okay. Okay. And in
Particularly,
UVM,
to practice this DFF, I have generated my own DFF block. I mean, I just design a small block, and over that I practice that UVM. Other than that, based on the UVM, particularly, I didn't spend much time in the big project. Right?
okay. Okay. So what projects you have worked in SystemVerilog?
In system so that ABB, AHBB, AHB driver thing.
Okay. So what you have verified in AHB is in SystemVerilog?
It's like APB. So we define in the APB and a slave. So we send the signals. Those 3 phases we have defined. So we check those 3 phases.
Okay.
How data is transferring.
Okay. Okay. So what is meant by interrupt
Interrupt.
in processor?
So
Yeah.
yeah. Okay. So interrupt is a process that we will use while program was in the RAM, while was loaded into the RAM. So everything will go by program counter. So for every instruction, program counter will be incremented to the next stage and next stage, next stage. So in particular cases, so we need all the process, what are the processes going on, and we have to dedicate these resources to some other important process that we have to calculate before completing this block. So in that case, these interrupt signals will come into picture. So in that scenario, what the processor will do is they will store this current PC value into a stack register, and this PC value will go to whatever the subroutine and interrupt have been defined there, and it will go there, and it will do that. This resource will be allocated for that interrupt operation, and after the completion of that interrupt operation, and PC will get the same value that was stored in the stack register, and it will continue the remaining process.
Okay. Okay. What is mean by paging, memory management?
Paging is like as I remember, there's like uh, efficient use of addressing that. Am I correct, ma'am? Uh, so paging in a sense, so it will have a virtual address. Physically, let's suppose we have an 8-bit address, but by using this paging concept, we will increase this address by using the memories inside the register. So we will first this 7-bit value will point to some other register, and this will have 32-bit value of register value, and this will go to 32-bit bit so that it can use those 32-bit value memory it can access. So it is a concept that as we are using only 7-bit, but inside the by using the manipulations inside the registers, we can use a 32-bit mapping of the registers.
Okay.
Am I
Okay.
correct, ma'am? Is that correct?
Yeah, it's somewhat you have certain you have reached, but not totally. One last question, one logical question. There are three sisters.
Okay.
One is Siri, Sarah, Serena.
Okay.
Three sisters, Siri, Sarah, Serena. Okay.
Okay.
So I will tell three statements. Just guess who are the youngest in those three. Okay.
Okay.
Siri is the oldest.
Okay.
Serena is not oldest.
Okay.
Sarah is also not youngest. So
Not
which of them is youngest?
So based on this point, based on the first statement, we can say that Siri is the oldest sister, and Serena is not oldest. So Serena
Serena.
will be the youngest. Yeah.
Okay. Okay. I'm done with your interview. Do you have any other doubts?
Yeah, ma'am. So can I explain where this question mean? What I want to know is that this SOC verification. It is like, ma'am. It was the thing that I have some connections to my college. So through my college,
Mm.
I have referred to this. I mean, my resume was sent to this guy, MD. Then I
Okay.
got a call from MD. I'm sending my resume to manager. So it is like I have a probable chance that I will get.
Mm.
So that's why I'm asking you that SOC verification question.
Mm. SOC verification means you are only college graduate only, right? So mostly they will ask on what is mean by SOC verification, what are different blocks in SOC architecture, and how would you do the SOC verification using the C language or by using the SystemVerilog, how we use the DPI, direct programming interface to C language, and what are the um, like concepts are there, computer organization concepts like memory management or paging or interrupts. These also comes under SOC verification. Okay, mostly what is the difference between IP verification and SOC? Only approach, as you are only the graduate, they will ask only the approach of SOC verification. I think the in-depth is not needed.
Okay, ma'am. So, ma'am, based on this thing, how you can rate me on approaching?
First two questions, okay, you need to improve the coding, but mostly coding will also, they will not ask as you are only graduate. So coding is not needed, just theory part only the interviews will ask. And in SOC verification, as per JD, it will depend. Okay, mostly SV, UVM only, and whatever the projects you have done, whatever you did, that all perfect only you are. But just in coding, you forgot the syntaxes and all, but that's not a big deal. They won't ask mostly coding wise. Okay, just go through some SOC concepts, and already you did risk by processor project, right? So you can apply that concept knowledge also. You can relate whatever.
Okay.
Okay. Any other doubts?
Yeah, ma'am. What are the other microprocessor concept that we need for SOC? This other than this memory management, paging, and so
Um,
that.
I will share the questions. Like mostly like interrupts and um related to the memory. So these will be the questions. I will share you those functional verification questions and these computer verification. Okay.
Okay, ma'am.
Okay.
Yeah, ma'am. So,
Any
ma'am,
other
also
doubt?
maybe I mean I mailed that guy for this JD. Maybe I will get in maybe
Okay.
next
Mainly
evening.
see what is meant by pipeline concept, cache
Okay.
concept. You already know hazards in the processor, so you can tell hazards if they ask. And mainly interrupts, cache memory, virtual memory, um, like subroutines or interrupt service routines, like instruction cycles. Okay, instructions, what is meant by compilation, these type of